Hi, this is Mato from BMI Academy. Question 4. This is JUPEB 2023, PHY 002. Question 4. State two similarity and two differences between image formed by a converging mirror and a converging lens. I take that again. For A, state two similarities and two differences between images formed by a converging mirror and a converging lens. Okay, the first thing you need to know is that both converging lens and converging mirror are very similar in the kind of images they form. A converging mirror is called a concave mirror. Concave mirror, while a converging lens is called a convex lens. Okay, both of them produce similar kind of images. So meaning you can tell a lot of similarity, but they have few differences. So going back to the question, it wants us to provide two similarities between their images and also two differences between the images they form. Okay. So let's start with the similarities. Similarities between a converging mirror and a converging lens. Okay, the both from real images. Okay, they can also both form virtual images. They can both form erect images. They can also both form inverted images. Okay, so these are their similarities. You just have to write any two of that. Then differences. The differences between a converging mirror and a converging lens. Okay. What could be the difference? I'm trying to think. Okay. We can talk about their focal length. Okay. Before that, let's talk about the positioning of the object relative to the image, or the positioning of the image relative to the object. For a concave mirror, if this is a concave mirror, realize that if an object is in the front of the mirror, when the image is formed on the side of the object, the image is going to be real. If the image is eventually formed on the other side of the object, the image is going to be virtual. But when it comes to a lens, you see through a lens, unlike a mirror where you look into a mirror. So a mirror works based on reflection, a lens works based on refraction. So if, for instance, you have an object on the left-hand side of the lens, if the image is formed on the other side, for instance, if this is the image, in this case, the image is going to be real. So, which is like the opposite case for converging mirror. So, one of the differences is that real images are on the same side of the object for converging mirrors or converging mirrors. While for real images, are on opposite sides of the object for a converging lens. So the point is, for mirror, real image is formed on the same side as the object. So if this is a mirror, the object and the image are on the same side for it to be real. But for lenses, if you have an object in this position, the image, if it is formed on the other side, the image gets to be what? Real. So that's one of the differences. And another difference is that for a convergent mirror, we have just one focus, while for lenses, we have two foci. One focus for a converging mirror, two foci for a converging lens. All right. Next question, B part, Roman figure 1. Mention any two uses of plane mirrors, concave mirrors, and what? Convex mirror. Mention any two uses of plane mirror, concave mirror, and what? Convex mirror. Okay. Let me create more space for that. I can this off. So we have a plane mirror. What are the uses? Number one, you use it as a viewing mirror. Roman figure 2, it's using a device called segment. Roman figure 3, it's used in the making of simple periscope. Then etc. The question just needs to from you. And we have a concave mirror. So concave mirror can be used as a shaving mirror. So it can be used in the head lamp of cars and vehicles. Okay, so what other uses do we have for concave mirror? etc. Then we have a convex mirror. Most time, convex mirrors are used for side mirrors of cars. You can also use it for security purpose. Security purpose. in a store or a supermarket because of its wide field of view. Okay, etc. Next question, it says, copy and complete the table below for the image formed by a concave mirror for different positions of the object. This is a test on how to draw ray diagrams. If you have seen my video on optics where I explain drawing of ray diagrams, this wouldn't be a problem. Okay, let me, okay, instead of drawing a table, I will just create a small snippet of this. Okay, so the question is asking us to complete this table. We have position of objects, position of image, size of image, nature of image. Then we have different positioning for the object. The first case is the object at infinity, at F. Okay, so let me quickly do a summary so that you understand this better. If this is a converging mirror, and we have this to be the principal axis, with this being the principal focus, and this being the center of curvature. The several positioning an object can be before the center of curvature, that is behind the center of curvature. The object can also be on the center of curvature. We can have the object between the center of curvature and the principal focus. We can also have the object on the principal focus. The object can be between the principal focus and the pole of the mirror. And the last case is having the object at infinity. And this different position also implies different characteristics for the images. When an object is placed behind the principal focus, behind the center of curvature, usually the image form is somewhere around here. It's going to be inverted, real, formed between F and C, okay? And it's going to be diminished. When you have the object position on the center of curvature, the image form is going to be inverted, form at center of curvature. It's going to be of same side as the object, and it's going to be real. For an object position between the center of curvature and the principal focus, the image is usually somewhere in here. If you draw the radar, it's going to be magnified, real, from behind the center of curvature, and it's going to be inverted. For a case where the object is positioned on F, the image will be formed at infinity. For a case where the object is positioned between the F, that's principal focus, and the pole, the image is usually formed somewhere around here. It's going to be magnified, erect, virtual, from behind the mirror. Okay, so these are the different properties of such image. So filling this table wouldn't be a problem if you understand how to draw ray diagrams. Position of object here at infinity. What would be the position of the image? Oh, I didn't talk about that. When you position an object at infinity, the image is going to be formed at what? F. This is formed at F. Or you simply say at what? At F. Following the way they presented their own. F being the principal focus. The size of the object, of the image, most likely going to be diminished. since the object is at infinity. The nature of the image is going to be real, since it's going to be formed on the side of the observer. At C, the image is formed at C. It's of same size and sort. The what object, meaning the size does not change. The nature is real. Between C and F, when the object is positioned between C and F, like from here, I tell you that the image is going to be formed somewhere around here. So which means it's going to be formed behind C. The size magnified. Or you say bigger, the nature of the image is still going to be real. When the object is at F, the image is formed at infinity. We can tell the size, we can tell the nature. Between F and P, when the object is positioned between F and P, like in this case, this is the object here, the image is going to be formed somewhere around here. So you can see that it is bigger. Let's first talk about the positioning behind the mirror. Behind the mirror. The size is bigger, that's magnified. The image is going to be virtual. Why is it virtual? Because as an observer, where do you stand? This is where you stand. As an observer, you stand in front of the mirror. So if you are in front of this mirror, see where the image is. Since the image is not on your side as the observer, that implies the image is virtual. So this is what? Virtual. So that's a summary of the problem. The question is asking you to do that. There are cases where they will just change this problem to what? For instance, convex lens. If they change it to convex lens, the things they are going to adjust in this table will be few. For instance, instead of using center of curvature, they will use statement like 2F. That's twice the center, twice the principal focus. So those are the things that will change. Instead of having a C expression, they will change it to what? 2F. The properties of such image are still the same for that of concave mirror. Convex lens and concave mirror, they have virtually the same kind of characteristic. But if it's going to be something like a convex mirror, irrespective of the position of these objects, the image is usually VED, virtual area to what? Diminished. So please take note of that. And a convex lens, a convex mirror has the same characteristic as a concave lens. Please take note of that. And that's the end of the solution. See you in the next video. Bye.